So this is the last presentation of the entire season, and this is Mediator Pattern. Let's start with a question. In an object-oriented software, how do objects communicate to each other? Using methods. So methods is something which is needed for objects to communicate. What else is needed? So I would typically have many objects in my application when it is running. If I have O1, O2 and O3 are the three objects, and if these objects need to communicate, so as I said, this is going to have one method and somebody is going to invoke the method of O2 if it is method M. Now if O1 has to invoke method of O2, what else is needed?
Has to be a pointer of O2.
Yes. So O1 has to have a pointer to O2. So the answer to this question is, the objects, they need to store the pointers to the object it has to communicate. That is the first thing. It has to have a pointer to the object to which it has to communicate. And then using that pointer, it is going to call the method of that particular object to which it wants to communicate. In a sense, what object-oriented paradigm refers to as communication between objects is basically invoking the method of the object using the pointer of the object. So that's what this picture explains. If I have 4 objects in my application, so this will have a pointer to this object, and then using this pointer it is going to invoke a method of this particular object. So as shown above, we talked about it, that in a sense there are 2 components. One is having a pointer to the object, and then using that pointer you invoke the method of the different object. So all this mediator pattern talks about is, it suggests an alternative way of enabling communication between objects. So this is before the pattern. And the mediator pattern, what it talks about is an alternative way in which these objects can communicate to each other. So this is the whole and sole purpose of this pattern. So let's start with an example. Now this example is from Eric Gamma, and this is implementation of dialog boxes in a graphical user interface. So this is one window. How many components are there in this window? So one is this window itself, and this window has multiple entities, I would say, or components. So the first thing is this list or the drop down menu. It is basically, you just choose the drop down menu and select one of the options which is available in that menu. So in this case, as it shows, it selects the new Century School Book format or something like that. So that is the first component. The second component is this weight. The weight indicates the weight, how heavy is that entity. So there are 3 options with that weight. One is medium, the second is bold, and the third is semi-bold. That is the second component. The third component is the slant, and that again has 3 options. One is Roman, italic, and oblique. And then you have a size, and then condensed, and then there are 2 buttons, OK and cancel. So in total, there are 1, 2, 3, 4, 5, 6, 7 components here. There are 7 components in this window. Now, typically what would happen is, each of these 7 components would be represented by one object. Each of these 7 components will have a class, and from that class, for this specific instance, we would have an object. So I would have an object for the first component, and then I would have an object for the second component, which is weight, and this is that drop down menu, and then for an OK button. Okay. Now so I have an object for the OK button. Now when this OK button is pressed, it has to check whether all the other fields has been filled or not. It has to ensure that an entry has been selected from this menu. It has to make sure that one of the weight values has been taken, unless it has a default, which is going to be most likely the case. And then there has to be a size specified. So this object, who all does it need to communicate to?
Only the last function will be sub-last function, so not last. Previous function.
Okay. So we said that, see, these are the components. So each of these components are represented by one object. So family is represented by one object. Weight is represented by one object. And then slant is represented by one object. So when the OK button is pressed, it has to communicate to all these objects. 1, 2, 3, 4, 5. And make sure it has a valid value for all the components before it continues it. So there has to be a communication between the object which is the object which represents the OK button with all the other objects. Correct? Now, if I select something over here, see, if I select this New Century School book, then will that require a communication between this family list object which represents this particular component to other objects? No?
Maybe or depends.
Yeah, it depends. So you said something?
I said same thing. It doesn't require, but you can do that.
Yes. So it may be required because if I select the value New Century School book as shown in this example, then what has to be done is this demi-bold is not an option which you can select with this particular font. So there has to be communication between this family list object and the object which is representing the center. So the point here is there are multiple objects over here and each of them they need to communicate to each other. So this was a solution which we talked about before the mediator pattern, which is each of these objects keeps pointer to the other objects. So OK keeps pointer to weight, it also keeps a pointer to list. OK also has a pointer to that font, weight, all the other objects. So it has to communicate. So this was the solution before using the pattern. This is how typically we would implement. Now an alternative to object communication methodology using the mediator pattern, which is what we are going to see. So the alternative would be as follows. I would have an object called list for the list, the first one. And this object has a pointer to a new object which is called as font dialog director. So this is a director object. And the list box has a pointer only to the director object. The list box does not have a pointer to the entry field or to the button class. The OK button object again does not have a pointer to the other objects in this object diagram. It only has a pointer to the director object. So what I essentially do is I introduce a common object which is called as a font dialog director. And all the other objects, they contain a pointer to this director object. And the director object also contains a pointer to these objects. Okay. Now, we have not yet seen how that whole thing is going to work. So what is this? What is this picture? Typically a ladder diagram like this, what does it represent? Sequence diagram. So this is the sequence diagram of how things would be between an entry field, a list box, a dialog director and a client. So these ladders, they indicate each of those objects which are there in that GUI. So the client would initially call the show dialog method of the dialog director. So show dialog is basically the one which is going to show the picture of that menu, of that window, and create all the corresponding objects. Now, So at the end of this first step, you see that picture, right? Where you have a list of all the fonts, then you have a weight, then you have a italics, and then OK button. And so this window gets displayed at the end of this step number 1. And then the user goes and selects a font from this drop-down menu. And when this is done, the list box object calls the method widget change of the director object. Earlier, how would things be? When somebody selects a specific item from that list, from that menu, drop-down menu, what would this do? Yeah, it has to. We saw that, right? For a specific font, it has to go and make some options not applicable for the weight and the italics, right? So it would be mandatory. It would be required that this object invokes method of an entry field or the other objects. But in this case, all it does is it calls a method called widget change of the director object, indicating to the director that there is some modification in me. And if you have to propagate this change to the other objects, feel free to do it. I don't know. See, this arrow indicates that it only informs the director that something has changed in me. And it says that something has changed in me, but I don't know what to do. So you better take care of it. I'm just informing it. And the director has the intelligence that, okay, let me first find out what the selection value is. So the selection value is going to give you the name of the font which has been selected. And then it knows that, okay, there is a font which has changed, and for this particular font, I need to, null out certain options. So it would call a method setText of the entry field. Okay, so this fellow has the intelligence of informing the other objects that there is a change like this which has happened. So this was the example of Mediator Pattern. So before and after. For this window, we initially saw that if the objects had to communicate without using the pattern, it would be directly invoking the method with the pointer. And with this pattern, this is how the sequence diagram is going to look like, and this is how the object diagram is going to look like. I have an object for list box, I have an object for entry field, I have an object for button, and then there is a director object which has a pointer to the list box, and a pointer to the entry field, and a pointer to the button. And these also they point to the director, and this is a central entity for communicating things. Okay, so example number 2, a very quick example. Now this is not as an example, but more of an analogy. So this picture shows 4 flights: flight 77, flight 112, flight 1011, and flight 747. Now all these flights are supposed landing on the Bangalore airport. Now without using the pattern, all these flights, how would they synchronize? See, landing has to be synchronized because there is only one runway. So they have to synchronize. So they would have to directly communicate to each other. So if this flight decides that I need to land on the runway first, then it would inform these other flights that, okay, I'm going to land now, so you guys, better stay away from the runway. But that approach has multiple problems, right? I mean, all of them, they would need to, have pointers to the other flights, or they need to know about the other flights which are about to land at the same point of time. So that's the reason, which has a whole lot of problems. So that's the reason you have an ATC, air traffic control mediator. So you have a mediator, and they just inform that I want to land now, or I want to take off now, and then the mediator actually coordinates the communication between all these 4 flights. So it is the responsibility of the mediator to communicate across all these 4 flights. Now example number 3 is that of users and groups in Unix. So all of us know that Unix has a concept of user and group. Like I was a user and my group was 3G1X. So the groups and users have different set of privileges. A file, for a file, a user can have read-write execute permission, and a group members can also have the read, write and execute permission. So basically, in essence, what I'm telling is that as shown in this figure, Jack is a user and Jack is part of how many groups? All the three groups. EDM, dev and group. Similarly, Larry is also part of all the three groups in this case. Because Larry points to EDM, Larry points to dev and Larry also points to group. Now, if all these, the groups and the users are represented using objects, each of the users would need to contain or store a pointer to the corresponding group object. Now, this is without using the pattern. Now, after the pattern, what we would do is, we would create another object, which is shown by this cloud over here, and this object is going to keep the mapping between the user and the group. And each of these users would just have a pointer to this class, which encapsulates this mapping. And the group also would have just a pointer to this object which encapsulates this mapping. So these are the three examples just to build upon why we possibly need a mediator pattern. So we would go through the standard way of the way in which we study design patterns. So the intent of the mediator pattern is define an object that encapsulates how a set of objects interact. So as in the case of the font, the first example, the director object was the object which encapsulated how a set of objects interacted. Mediator promotes loose coupling by keeping objects from referring to each other explicitly, and it lets you vary their interaction independently. So this is the advantage of the mediator pattern. In all the three examples which we saw, the main thing which we achieved there was loose coupling. The set of objects which needs to communicate to each other, they are not tightly coupled. All they know is just a director object, and the director knows how the object has to communicate to each other. So mediator promotes loose coupling. That's the benefit of mediator pattern.
Okay, I'm getting confused with bridge pattern. Same
Okay.
thing does the bridge pattern also. So how to relate it?
No. Does means bridge pattern has a different purpose, right?
Similarly, if you see the diagram,
Yeah.
purpose would like similar to. So when to use the bridge and when to use this?
See, bridge we had one object and another object. Like we saw the example of pilot classification, right? And then bridge is basically there are two inheritance hierarchies. Okay, this is one hierarchy and this is the other hierarchy. And you would bridge them. That's the bridge pattern. Okay. But here it is, the purpose over there is to bridge. We saw the example of the stack in the bridge pattern. So there was a stack and there was a stack implementation. So here the problem is not to solve how these objects would communicate. Here it was more of separation of abstraction from implementation. That was one objective of the bridge pattern. And then the other purpose was, if there are two inheritance hierarchies, like we saw the example of Unix PTS and then Windows PTS and Java PTS. So they itself were two hierarchies, and then we just wanted to bridge those two hierarchies. So the purpose was totally different. The purpose over here is to enable, to provide a better way of how the objects can communicate. Okay. So this is the structure of my mediator pattern. Okay, so let's start from this part. So I have a colleague, and then this colleague has two objects, two classes derived from it, which is concrete colleague 1 and concrete colleague 2. So now, if I go back and look at this hierarchy, how does it map to the first example? Which objects map to concrete colleague 1 and concrete colleague 2? Sorry? Okay, right. So the family was actually an object, a list object. So the list object is my concrete colleague 1. Similarly, OK button. OK button was also an object. That is my concrete colleague 2. And then we had other things like font and weight. So each of those things were objects. So in a sense, the right part of the tree, the right part of this picture, which is colleague 1, colleague 2, these are actually the objects who has to communicate. Okay. Now the left part is, so if I don't use mediator pattern, we will have only these things. And all these are objects which has to communicate to each other. So they would keep pointers to each other. And then they would communicate directly. So the left part of the picture, which is mediator and concrete mediator, comes into picture only if you want to make use of this pattern. So I have a mediator class and a concrete mediator class. So, I mean, just for the purpose of generalization, it just shows that the mediator class can also be inherited. I mean, you can have inheritance over here. So, which class in the first example map to these two? Right, the font director, because that was the one which was enabling communication between these two objects. So the mediator or the concrete mediator is a font director. Now as you can see, so this is about this inheritance. Now this has to have a pointer to the mediator, and the mediator also has to have a pointer to the concrete colleague 1 and concrete colleague 2. Right? So this is the structure of the mediator pattern. Right? Any questions on this? Who has to have it? Okay. So it's the same thing as why director has to have a pointer to. Yeah. So let's go with this example. Now, so in essentially, if I map your question to this example, the question is why should a director object have a pointer to the interface object? Correct? Yeah, the mediator has a pointer to the colleague, right?
Yeah. So concrete has a pointer to other concrete colleagues, right?
Concrete has a pointer to the.
In colleague 1 and colleague 2 pointers. I didn't understand what is the relation between the mediator and colleague pair.
This one?
Yeah.
Okay.
If you're showing that mediator will have a pointer to colleague, then the colleague could be either concrete colleague 1 or 2, right?
Yes.
Then you don't need that concrete mediator having pointers to colleague 1 and 2.
Okay, so you're asking this one, why is this pointer needed here or why is this pointer needed here?
I'm asking why you need both.
Both of
You
them.
have one of them as well.
Oh, one of them is, because see, this will also needs to call the method of mediator, right? Like we saw the first example of widget change. So if there was a change in the list, the moment you selected one of the entries in that family, so it has to inform the director. So that's why this concrete colleague 1, concrete colleague 2, they need to have a pointer to the mediator, just that it's moved to the base class.
I
Okay.
have another question.
Okay.
Does it mean that concrete colleague 1 and 2 should be of the same type?
Need not be.
Separate, independent.
It can be separate, but yes, if you have it, then it simplifies things because the mediator can have a pointer to the colleague itself. And then, but yeah, of course, in this case, it has shown that this is a pointer to concrete colleague 1, concrete colleague 2. But if they are actually both derived from the same base class, then instead of having two different concrete pointers, it can just have a pointer to colleague object. See, I can have either this, okay, so colleague PTR2, okay, or concrete colleague star PTR1 and concrete colleague 2 star PTR. So both the ways it is fine, but if both of them are derived from the same base class, which might be possible in a large number of cases, then you can have the same base class type over there instead of having two different concrete pointers. Right.
So the pattern doesn't enforce that.
No, it doesn't. The pattern doesn't enforce that. The most essential part of the pattern is about mediator. See, the pattern also doesn't enforce that you have to have a concrete mediator. Only this mediator can be there. And then there could be, concrete colleague 1, concrete colleague 2, and they can have a pointer to the mediator. Okay, so the participants are mediator. So mediator defines an interface for communicating with colleague object. So the base class, it only talks about interface. So base class generally have virtual methods. So it would actually not implement the methods which are used for communicating with the colleague objects. And then you have a concrete mediator. Concrete mediator implements cooperative behavior by coordinating colleague objects. It knows and maintains its colleagues. And then you have the colleague classes. Each colleague class knows its mediator object. And each colleague communicates with its mediator whenever it would have otherwise communicated with the other colleague. So this is how now the last diagram which we saw, this is a class diagram. Now from this class diagram, this is the object diagram we would see, and this is again from Eric Kramer. So again the same thing. I mean, if you map this to the first example, these are the objects which has to communicate, and without pattern, they would have pointers to each other, and they would call the methods of each other. And this is a mediator, a complete mediator object which has been added because we want to make use of the mediator pattern. And now these objects has a pointer to the mediator object, and the mediator also has a pointer to all these objects, and they cooperate with each other to make the communication happen. So few points. So it centralizes control. Now this pattern competes with the publisher-subscriber pattern. In publisher-subscriber pattern or the observer pattern, what you have is one class which is the subject. One class you have the subject, and then there are multiple observers. And if there is a change in state of this subject, all these observers would be interested in knowing the new state. So we saw the example from the SDF code for a publisher-subscriber object, that when a message comes, then there could be objects who have registered for those messages. So this fellow would pass it on to the multiple observers. So that is more of a change in the subject. That information has to be propagated to multiple observers. So it is push of data from here to there. They are observers. They are not actually, sending it back. See, you are getting it only. In case of observer pattern, they are only the recipients of data or recipients of the new state, but they are not sending it back to somebody else. But this is more for, communication between these two objects. And the third bullet is it decouples collision. So of course that is something which we have already discussed. Okay, so there is a power cut or?